Hey guys, so this worksheet here is going to be due tomorrow. I know this is kind of late for me. It's like 11:24 as far as getting something out for you, but I actually just made this morning, and I'm going to give you a little bit of notes. So I'm really going to try and keep this less than 10 minutes, something very quick, short, to the point of what electrochem is, redox reactions, transferring electrons. So this will be due tomorrow, 9:30 for class, and I will go over it with you. So I will attach this. I haven't posted it yet, but I will. All right. So I left off with this yesterday, and this kind of sums up what electrochem is. And you could say electron chemistry instead of electro because it's all about electrons being transferred. Now, we've learned already that in ionic bonds like this, MgO, you have a metal, nonmetal. The metal gives electrons to the nonmetal. And when it does that, they form ions, cation, anion. And opposites attract. They come together and make a crystal lattice structure. All of this should ring some bells, hopefully, even though it's been a while. So that's essentially what redox, when I say redox reactions are. Redox means reduce and oxidize, and reducing and reduction and oxidation are two terms that really encompass electrochemistry. So when you have a very simple synthesis reaction like Mg plus O2 creating an ionic compound, Mg plus 2O minus 2, this is an example of a redox reaction. It's also part of electrochemistry, the topic, the unit. So what have we learned and how does that help us now? Well, again, metals lose electrons, become cations. They're positive, right? Positive. Some of us really enjoyed that. And then oxygen gains those electrons and becomes negative, an anion. So this down here just kind of explains it a little further. So the Mg went from a 0 to a plus 2, 0 to plus 2. This was Mg. And then the O, oxygen, O2, but really each atom, each O went through this. So I'm just going to write O for oxygen. The oxygen went from a 0 to a minus 2. Well, what happened? Well, the Mg, again, lost 2 electrons. Where'd it go? Gave him the oxygen, right? Played pitch and catch. All right. So this, I'm just summarizing what I said yesterday, kind of explains in a nutshell what redox means. I'm going to do this again. I'm just going to give you another example, explaining these terms, and then hopefully be able to do the work, the homework. So I'm actually going to leave this here. That's right. Here we go. Okay, so let's do a different color today. Let's go. I really like this blue right here. All right, here we go. So the term redox means reduction and oxidation. And the phrase of the day, the acronym of the day will be Leo Gur. And there's a phrase, Leo the lion goes Gur. That's a G. My G's are bad. So Leo Gur is an acronym to help you understand how electrons are transferred and how does that apply to these two words here, reduction and oxidation. So here it is. Leo means lose electrons, E minus. Let me erase that and make that a little bit better. So electrons oxidize. Lose electrons, oxidize. All right, I know I'm abbreviating. Lose electrons, oxidize. And then Gur, maybe I should write it over a little further so I have more room. So Gur, gain electrons. And I bet everyone watching, hopefully a lot of you, will get this, reduced. So in a chemical equation, in a chemical reaction, any chemical reaction in the entire world, universe, in your body, wherever a reaction is occurring, if there is a transfer of electrons, somebody, an element, ion, molecule, compound, something, they're called species, some species is being oxidized because it's losing electrons, and some species is being is being reduced because it's gaining electrons. So you can't have one without the other. Somebody always loses electrons, somebody always gains electrons. Any kind of redox reaction, both of these are happening at the same time. You can't have reduction without oxidation. You can't have oxidation without reduction. It's like trying to throw a frisbee. You go to a park, go out in a field, your front yard, backyard. You want to throw a frisbee. You can't throw it with yourself. Okay, you want to play catch with a baseball, football, kick a soccer ball around. You can't play that with yourself. Yeah, you can argue. Oh, what about a boomerang? Kids have said. Okay, yeah, well, forget boomerangs. And kids say, well, what about a wall? If you have a wall, you can throw a ball off the wall to bounce back, or kick a ball and it'll come back. Yeah. There's always things you can say, right, to kind of dispute what I'm saying. But in general, I think you understand what I'm saying. You want to go play catch, you need two people, right? So somebody is losing the ball, the electron, throwing it. Somebody's gaining the ball, the electron, or whatever it is. Okay. So hopefully that makes sense to you guys. So this is the biggest thing I can teach in limited time, in limited formats here with redox and electrochem. And those of you taking AP Chem next year, this has to be like really, really easy to you. So this is important. Leo, Ger, lose electrons, oxidize, gain electrons, reduce. All right. So last thing I'm going to say with this before I give you one example, and then that'll be it for you. That'll be it for this, and hopefully enough to do your homework, is over here, the oxidation numbers, which is a charge, all right, oxidation number will always increase. And over here, the oxidation number will decrease. That's where the word reduce comes from. If an element or an ion gains electrons, their charge actually goes down. Why? Because electrons are negative. So oxidation numbers decrease over here, and then over here, oxidation numbers increase. Here's an example. If sodium gets rid of one electron, it will turn into Na plus 1. So if sodium loses one electron, it becomes Na plus 1. But over here, if fluorine gains an electron, it becomes F minus 1. So gaining electrons makes it negative. Losing electrons makes it more positive. So more positive, more negative. The better way to write these actually is like this. Okay. So I'm kind of giving you an example to help with the homework. If sodium here, which is neutral, it has no charge. We've learned that before, but some of you might be like, what is he doing? Sodium is an element. It's an atom. And elements and atoms in their natural state, pure state, are neutral, no charge. It only gains that, it only has that plus 1 when it's in a compound. And when it's in a compound, like an ionic compound, it's going to lose its electron. So I'm sorry if I'm saying too much here. So let me recap. Sodium is neutral as an element. When it loses this electron, it now is a plus 1 ion. So losing an electron, it becomes positive 1. That's called oxidation. So we would say sodium, Na, is oxidized. Over here is the opposite. Fluorine is 0 as an atom in a pure state. It gains an electron and now turned into F minus 1. It gained an electron. The charge went down from a 0 to a negative 1, decreased, reduced. So we would say F is reduced. So Na is oxidized, F is reduced. So if I was to put this together in a reaction, it would look like this. Na plus F2 yields NaF. And it's 2 because it's diatomic. I would need 2 of those and 2 of those. Okay. So on your homework, what you're going to do, I'm going to give you a balanced equation. You have to label the oxidation numbers on all the elements. Species is a word for it. This is a species, that's a species, that's a species. So species just means atom, element, compound, ion. All right. So sodium and fluorine as elements are neutral. They have zeros. Sodium and fluorine in a compound, you would use your periodic table to look up their charges. Na plus 1, F minus 1. This should not be new. You should be like, yep, I get it. So now Na is now plus 1 in this compound, and F is minus 1 in this compound. Why? Well, because Na was oxidized. It lost electrons and became positive. That's Leo, right? Oxidized, Leo. Fluorine is reduced. Why? It gained the electron that sodium lost. So sodium gives fluorine electrons. And actually, since there's two of them, it gives 2 electrons total, 2 E minuses. Each Na gives each fluorine 1 electron. So another way to kind of show this down here is you have this Na here giving 1 electron to this fluorine here, and then this Na here gives 1 electron to this fluorine here. So each Na, right, there's 2 of them, and there's 2 Fs. Each fluorine gains 1 electron, and each Na loses 1. So over here, I actually have 2 NaFs, both doing the same thing. This Na is plus 1, this F is minus 1, this Na is plus 1, this F is minus 1. It's just the 2 means there's 2 of them, that's all. There's 2 of them. So I hope this was short enough and explained well enough that you can do the homework. I also give you a whole example on the homework, like I do a whole problem for you. So between this video and my example, hopefully you have a good idea of how to do this, and we will go over it tomorrow. So I'll use it to help teach it again tomorrow. I don't expect you to fully get everything right now, okay? But hopefully this helped, all right? So again, Leo, lose electrons, oxidize, gain electrons, reduce. You just have to follow the electrons and then look up the charges on the periodic table to figure out who's losing, who's gaining. All right, so I'll stop there. I'll see you guys tomorrow.